Class, what is up? We're moving actually to our last section. Don't worry, our test isn't for a while, but we're going to spend a good amount of time on this 8.4 section about angles of elevation and depression. Basically, we already have all of the skills that we need, like we know the trigonometry, and basically what we're doing now is we're putting a little bit of a real-life twist to trigonometry, alright? So, gotta understand what an angle of elevation and an angle of depression are. And so the angle of elevation is an angle formed by a horizontal line. Gotta be horizontal. That's a big sticking point. It's always from the horizontal line. And a line of sight to a point above the line. Alright? So if we look at this picture here, if we're here at point T, or at the the tower, shoot, I can't think of what it's called right now. Anyway, we're at the tower. Well, if I draw a horizontal line, or a line straight out to the right, and then I'm looking up at the plane, well then this right here is my line of sight to the plane, and again, because the plane is above the horizontal line, this is called an angle of elevation. So angle 1 is the angle of elevation from the tower to the plane. Alright. Well, now we need to also kind of define angle of depression. Alright, depression just means that it's going down. Alright. So now, angle of depression is the angle formed by a horizontal line and a line of sight to a point below the line. Alright, so now when we look, for example, maybe we're at the airplane, we have this horizontal line drawn, and we're looking down, so our line of sight is going down to the tower. Well, the angle formed between that horizontal line and the line of sight is the angle of depression. Okay, so the angle of depression is from the plane to the tower. Now, conceptually, I hope that you guys, and they have it marked here, why do these both have single arc marks? Well, because they're congruent. These angles, angle 1 and angle 2, are congruent. And the reason is because, so horizontal lines are parallel, and that's the ticket. Alright, in my picture here, I know that this horizontal line and this horizontal line are parallel. And so once we have parallel lines, we know that when they're cut by a transversal, that the alternate interior angles are congruent. So now we just kind of have to fill out this section down here at the bottom. Since horizontal lines are parallel, angle 1 and angle 2 are congruent by the alternate interior angles theorem. Therefore, the angle of elevation from one point is congruent to the angle of depression from the other point. Alright? So angle 1 from or at point T, and this angle that's going up is exactly the same as the angle from the plane going down. Alright? And that's useful. We're going to use it. So this next page right here, we would want to practice this. We want to see if we can recognize what angles we have going on. I'm hoping that this will be fairly straightforward and easy. When I look at angle 1, well, angle 1, I'm at the top of the mountain, and I'm looking basically down to this person. So if I'm looking down, then it's an angle of depression. Alright. Angle 2 is actually now from this person who's looking up at the mountain, keyword being up. Well, if we look up, we know it's an angle of elevation. when we take a look at angle 3, well, still talking about this person, but now what's happening? They're looking down at the cabin. So angle, or looking down, angle of depression. And lastly, angle 4. Angle 4 is right here. Angle 4 is from the cabin up to the person. Up being the key word, angle of elevation. Alright, now I'm going to skip this next example for right now. If you want extra practice, please feel free to do it, but I think we should be okay on that. And what we're going to do is we're going to move on. We're going to start figuring out how to solve these word problems. So, steps for angle of elevation and depression word problems. Please star this. Please understand that this section right here is super important, and it will be very, very helpful while you're trying to learn how to do these problems. First thing, we need to draw a picture to represent the situation. Seems familiar. I think we just did this on our quiz. What's really nice is this picture will always create a triangle. And you know what? I should even be more specific. A right triangle. All right? Well, once we have a right triangle and we can label things, right? So we have sides and whatnot, we can figure out what trig function we need to use. And then once we know what trig function to use, we can set up an equation and solve. All right? So we draw a picture, we label, you know what? I'm going to add actually 1A. 1A. Label everything you can. All right? So I added a little step in there. All right, let's take a look at something like number 1. So read first. You see a rock climber on a cliff at a 32-degree angle of elevation. The horizontal ground distance to the base of the cliff is 1,000 feet. How high is the rock climber above the ground? Round. Okay. So you see a rock climber on a cliff at a 32-degree angle of elevation. So that means that I'm probably down here on the ground, and then maybe there's a rock here and there's a little cliff, okay? And I'm looking up at this cliff, and this is where I see the rock climber. I'm not a great drawer, so I'm going to say climber, and I'm going to say me. And now I know that I am looking up at the climber. So I need to draw the line of sight. Alright. Now this doesn't look too bad, but remember, we want a triangle. We want a right triangle. So I'm going to finish this by drawing a full right triangle, because now I can label some things. Well, I knew that the angle was 32 degrees. So 32 degrees goes right there, right? That's the angle of elevation from horizontal up to the climber. The horizontal ground distance to the base of the cliff, well, that's 1,000. And because it's the horizontal ground distance, I have to put it along the ground. The last thing, it's asking for how high is the rock climber. If I want to know how high the rock climber is, am I looking for the distance that I am away from the climber, or do I want to know the vertical distance? I want the vertical distance. And so we need to understand then that I need to put my variable right here. I need to solve for this. I don't care about the hypotenuse. And I hope that makes sense. Now we're ready to solve. If this is my angle that I have, 32 degrees, well then this is my opposite, this is my adjacent, this is my hypotenuse. Well, I don't care about the hypotenuse. I have x on my opposite, adjacent, OA, tangent, TOA. Alright, so I know that I'm going to use the tangent of my angle, and that's going to have to equal my opposite over adjacent. Opposite over adjacent. And holy cow, this is exactly the same thing that we've been doing, okay? We just took a quiz on all this. I just gave you a picture, and made you do a little bit of work to get to our equation. Because now I do the same thing. I cross multiply, I get x is equal to 1,000 tangent of 32. And if we have our calculator, let me grab one real quick, sorry guys. If I have my calculator, I just type in 1,000 tan 32 and I get my answer. Now, it does say to round to the nearest tenth of a foot, so x equals 624.9 feet. If I just want tenths, then I need to look at the second decimal place and round my first decimal place to 0.9. All right? Let's do a couple of more of these. All right. The pilot of a plane is flying at an altitude of 2714 meters. Altitude, anyone remember? What do we know about altitude? Anyone fly on planes a lot? Altitude is just height. All right. And then we know that the angle of depression as the plane descends is 3 degrees. So how far away from the runway is the airplane? All right. Well, let's think about this. We know that we're going to have our plane, and we know that the angle of depression, so straight from a horizontal, angling down, I know is 3 degrees. And let's see, what else do I know? Well, I know that the height of the plane, right? So here's the ground, and then the runway. I know that the height is 2714 meters. All right, so 27, something like this. All right. Well, here's the thing, guys. I know all this information. The problem is, I'm always going to turn my angle of depressions into elevations, all right? And we can do that because we know that the horizontals are parallel to each other. So I know that if this is 3 degrees, well then this is also 3 degrees. And the triangle I'm looking for then, I know it's going to be covering up a little bit, is right here. All right? This is the triangle I'm looking for. So, I have my angle. I'm going to rewrite. This is 2714 meters. I know that this is a right triangle. And then I need to figure out where I'm putting my variable. Do I want to know the hypotenuse, or do I want to know the ground distance? So we have to go back and we have to read. It says, how far away from the runway is the plane? Well, if we're talking about how far something away is from the, or how far away the runway is from the plane, I probably want to know the land units, right? Like I want to know how many more meters do I have to go here to get to the runway. So I'm going to put that on my horizontal distance because that's what we talk about. Like when we're talking about how far away we are in an airplane, we're talking about horizontal distance. Okay. So now, let's see here. I have my angle, I have a side, I have the unknown side that I'm looking for. I think I'm ready to set up a trig equation. If this is my angle, then this is my opposite, and this is my adjacent. So once again, I'm using tangent. This time I'm using the tangent of 3 degrees is equal to opposite over adjacent. So 2714 all over x. And then we either cross multiply or we remember that when x is on the bottom, we can always flip it. So we know that we are going to do 2,714 divided by tan 3, and I get, ooh, that's big, x equals 51,786.2 meters. And there we have it. All right. Okay, last one. Let's set up a picture. A rescue diver working for SeaWorld spots an injured sea turtle that is 27 meters below the surface. Okay, he needs to dive at an angle of depression. All right, so we have a diver. And it looks like we have a sea turtle. And we know a couple of things. Let's first say we know that this diver sees the sea turtle at an angle of depression of 43 degrees. But if you remember correctly, we're always going to switch our angle of depressions to angle of elevation. So we're going to think, instead of going from diver to sea turtle, we're going to think sea turtle to diver, because that's what's going to let us set up this right triangle. All right? But again, we have to remember an angle of depression is the same thing as an angle of elevation. So if this is 43, this is 43. Now that we have our triangle drawn, let's see what's going on here. Well, we know that the sea turtle is 27 meters below the surface of the water. So that's like a vertical distance, or a vertical height. So I know that I can put 27 meters along the vertical. And let's see here. How far will the rescue diver have to swim to reach the sea turtle? This question I don't necessarily like, only because, again, when I talk about distance, I tend to care more about like how far in a horizontal direction. But technically, if we're swimming from the diver straight to the sea turtle, then in this case, I'm looking for the hypotenuse, right? I want to know exactly how far away is the sea turtle from the diver. So I would have to call that my hypotenuse, or my variable would have to be my hypotenuse, excuse me. All right, so we set this up. Picture looks great. Here's my angle, which means I have an opposite and a hypotenuse. So now I'm working with sine. The sine of my angle, 43 degrees, must be opposite over hypotenuse, 27 over x. And of course we can write this as x equals 27 over sine 43, right? We can flip these. And I can go to the calculator. So 27 divided by sine 43. 39 point, if we're rounding, we should go to 0.6. Yes. X equals 39.6. And I believe it was meters, right? Yeah, meters. All right. So, big things. Big things to take away from this video. You have to understand pictures, right? You gotta draw a picture. It doesn't have to be beautiful, like these pictures aren't great, but every single picture needs to be a right triangle. And then you label absolutely everything you can, because once you label everything, you can figure out what trig functions to use. And of course, once we have the trig functions, then we can write equations and solve. All right. The last bit of information that is super important, and like the key to unlocking these problems, is down here at the bottom of the first page. If we have horizontal lines, and we understand that horizontal lines have to be parallel to each other, well then when we draw in that transversal, the line of sight, your angle of depression and your angle of elevation will always be congruent. So again, that we needed here. On these last two problems, I knew that it gave me an angle of depression of 43 degrees, but I knew that that 43 degrees had to match with the 43 degrees down at the bottom. Okay? So I know this was a little bit longer of a video, but I'm hoping that it was a nice introduction to drawing these pictures and solving some more problems that are a little bit closer to like real world, real life examples. All right? Have a great day.